Assalamualaikum and very good day to our behavior lecturer, which is Dr. Haryani. Today we want to present our group project, which is process state simulation and visualization. So let's go. So our agenda is only three, which is explanation of process states and their meanings. Number two is demonstration of process state transition. And then lastly is discussion of challenges and learning outcome.
Okay, now I will explain about the process state and their meaning. So this slide explains five main process state in operating system. Okay, for the first one is new state. New means a process has just been created. And the next is the process entered the ready state, which is the second state, where it waits for the CPU to be assigned. Okay, when the CPU start working on the process, it will move to the running state, which is the third state. And then, if the process needs to wait for the input or output, such as reading a file, it enter the waiting or block state. And finally, when the process finish its task, it will move to the terminate state. So these five states show the life cycle of a process from creation until completion.
Alright, Assalamualaikum and good morning, everyone. Today, I will continue our presentation by presenting operating system process state simulation, which it will demonstrate on how processes move between different states using the first come first serve scheduling algorithm. And then our presentation covers four sections, which is process information here, state transition timeline, Gantt chart, and lastly our simulation dashboard. Okay, let's go to the first one, which is process information. As you may see, it has P1 and P2 and P3, where P1 arrival is 0 and have a burst time, CPU burst time of 5 unit. Also requires CPU IO for IO request time for 2 unit. And then for P2, it arrive at time 1 and has CPU burst time at 4. And P2 doesn't request any IO operations. And then lastly, P3, it has arrived in time 2 and also has a CPU burst time of 3 unit. And it also requires IO request time for 1 unit. And then this table also calculates 3 performance measurement, which is turnaround time, which is for to calculate the total time from the process arrival until completion. And then for waiting time, it for the time spent waiting in the ready queue. And then response time is for from arrival until the process first receive the CPU. And as you may see, P2 is the shortest waiting time because it doesn't request any IO interruption. And then the P3 is the most longest waiting time because it arrives after P1 and P2. Okay. Finally, this is the simulation dashboard where it will display the current time, the process using by the CPU, and the CPU state of P1, P2, and P3, the ready queue, the waiting queue, and also the explanation of the current event. So when I start the simulation, the dashboard will automatically move through the each step. First, I will reset the simulation first. Okay, and then let's start the simulation. So one the main features that I put in the Excel, which is the highlighted row in the timeline and the marker at the Gantt chart also change according to the current time. For example, let's say time 6, we go to the select time. Here we saw the overview, right? But we also can view the information also in the state transition timeline where it will highlight the time 6 and what we can get the information is, and also we can know what CPU process where the CPU process currently being, which is 8 times 6 here. It will process P3, right? Okay. So for example, we can also reset the simulation as I do previously to return to the dashboard to its original conditions. So in conclusion, this simulation demonstrates on how the FCFS scheduling algorithm manages several processes and how the I/O operation affects the execution order. It also helps to understand process state, ready and waiting queue, CPU allocation, also scheduling performance. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdulrahman Musa Muhammad. For this slide, I will explain the challenge we have faced in our assignment. The first challenge was tracking process state transition because several processes have moved between ready, running, waiting, and terminated. The second challenge was simulating I/O operations manually because I/O would change the process from running to waiting, then back to ready. Because of that, creating the state transition table and Gantt chart was difficult for us, and we had to revise them, memorize them, make sure the timing and order were both correct. That's all for the challenge. Thank you.
Right. So lastly is discussion of linear outcome. So from our discussion, all this is about what linear outcome that we got. So this assignment provide practical exposure to the concept of process management and CPU scheduling in operating system. Through the simulation, several important learning outcome were achieved. First is we gain a comprehensive understanding of the five fundamental process states, which is new, running, ready, waiting, and terminated. Second, we learn how process transition between different states throughout their life cycle and how these transitions are triggered by scheduling, decision, and input-output operation. Third, we develop a deeper understanding of the first come, first served scheduling algorithm, including its advantage, disadvantage, and non-preemptive nature. And then we observe how input-output operation affect process execution and contribute to increased waiting and turnaround time. And then we learn the importance of performance metrics such as CPU utilization, waiting time, and turnaround time in evaluating the effectiveness of scheduling algorithm. And then the non-programming simulation approach enhance our ability to analyze operating system behavior using tables, diagrams, and scheduling model. Lastly, this assignment strengthened our analytical problem solving and teamwork skills while applying theoretical operating system concept to a practical simulation scenario. So that's all from us. Thank you.